Hello, bonjour. Alright, qegħdin tisimgħuni? Hello? Hello, alright? Qegħdin tisimgħuni? Ħadsew? Mela, l-ewwel ħaġa iċċekkjajt il-VLE u proset għax prattikament kulħadd qed jidħol. Alright, jiġifieri naf li qegħdin tidħlu tiċċekkjaw l-affarijiet li għandkom bżonn, eċċetera. Mela, il-bieraħ tajtkom ftit xogħol x'tagħmlu, alright? ħanara daqxej, ħanikorreġu dawk li għamilna li tajtkom il-bieraħ, ġifieri we had some conversions to do, alright? Let's work them out. Mela, I'm going to show you. Okay. Mela. Alright, so these were the questions. The exercise that I gave you. Mela. Alright. So yesterday we worked A and C. Alright, we worked A and C. So let's work out the rest. Alright, so let's start with B. Mela B, we have 12 millimeters. We have to change it into the SI unit, which is meters. So, millimeter, milli is equivalent to 10 to the power of what? Isa? Minus 3. Okay? Dawn huma li tridu titalmu, right? You have to study, this is the most important thing. You have to study the prefix and what does the prefix mean. So, from millimeters to meters, we have to multiply by 10 to the minus 3. From meters to millimeters and the other way around by 10 to the 3. In this case, we're converting from millimeters to meters, so it's very simple, 12 times 10 to the minus 3 meters. If you want to write it in a formal way, then 10 to the minus 3, we have to move the point 3 times backwards, or vera. In this case, it has been already moved, so we just have to move it 2 times. So it's 10 to the minus 2 meters. Kif għattilkom il-bieraħ, the first answer, 12 times 10 to the minus 3, it's already correct. Alright, if you want to leave it like that, it's perfectly correct. But the other way is a more formal way how to present your answer. Okay. C we worked sorry, A and E għamilna. Mela C 832 kilometers in meters. Now, kilometer, kilo means 10 to the 3. So to move in the direction times 10 to the 3, in the opposite direction times 10 to the minus 3. We're moving from kilometers to meters, so 832 times 10 to the 3. If we want to write it in a formal way, in the question, he is asking us to give the answer into significant figures. So I'm not going to write 8.32, I'm going to write only 8.3 because too significant. Alright? So 8.3 times 10 to the 5 issa, għalix? Għax 832 times 10 to the 3 jiġi jekk. So 8.3, jekk nitfaw il-point ta' għanna 1, 2, 3, 4, 5. Okay? Therefore, it's 8.3 times 10 to the 5 meters. Sound alright? Any problems? Okay, so sissa, kulħadd? Tajjeb, ħankomplu. Mela, D. We have 546 nanometers. Nanometer is equivalent to 10 to the minus 9 meters. So if we move in that direction times 10 to the minus 9. So it's 546 times 10 to the minus 9 meters. If we arrange it, to 5.5 times 10 to the minus 7 meters. Alright? Komplejna. Mela hija minnija F. Issa F jista' jkun kien hemm min kellu xi problemi fiha. So F is 500 T. I didn't mention what T is. Do you know what T is, small t? Huh? Tons, Iva, tajjeb, tons. Alright, now, tons obviously it's not an SI unit. Alright, but in physics we use it a lot. For example, in architecture, when you have steel structures, alright, we use tons to be able to measure the mass of those structures. Alright, so we use tons a lot. In 1 ton, jew inkella niktbu 1T, do you know how many kilograms are there? 1,000. Eżatt. 1,000 kilograms. So to move from tons to kilograms, we have to multiply by 1,000. Therefore, this is equal to 500,000 kilograms. If we write it in standard form, it is 5 times 1, 2, 3, 4, 5. 10 to the 5 kilograms. Alright? Tajjeb. 1 to 3 milligrams issa. 1 to 3 milligrams. Mela għanna. Milligrams. Issa, here we have the problem of mass as usual, alright? The SI unit of mass is kilograms. So first we have to change milligrams into grams and then grams into kilograms. We have to do it in 2 steps, alright? So milligrams is 10 to the minus 3 grams. So to move from milligrams to grams, we have to multiply by 10 to the minus 3. Mela ħaniktibaw. So first I have 1 to 3 times 10 to the minus 3 grams. Okay? But then I have to change grams into kilograms. So if you studied the prefixes, kilogram means 10 to the 3 grams. Kilo means 10 to the 3. So if we're moving from kilogram to grams, we have to multiply by 10 to the 3. But if we're moving from grams to kilograms, as we have to do, we have to multiply by 10 to the minus 3. Fimni għadi? Mela l-ewwel qed niktiba kilogram hija 10 to the 3 grams. Imbagħad qed ngħid minn kilograms għal grams mela times 10 to the 3. Mela minn grams għal kilograms bil-kontra irridu 10 to the minus 3. Therefore, I will have 1 to 3 times 10 to the minus 3, that's the grams, times 10 to the minus 3 to convert them into kilograms. Kulħadd qed jifhem? Alright, kulħadd alright? Everyone is understanding? So the answer would be 1 to 3 times 10 to the minus, if I have 10 to the minus 3, 10 to the minus 3, then together they will be 10 to the minus 6. Exactly. Alright, issa, either you leave it like that, or else, if we want it in a formal way, it will be 10 to the minus 4 kilograms. 1.2 times 10 to the minus 4. Alright? Tajjeb? 10 to the minus 6, 1, 2, 3. We can do, alright, 10 to the minus 4. Tajjeb. Okay, Sawnek? Alright, let's move on. H, 2.3 micrograms. 2.3 micrograms. So here we have exactly the same problem. Alright? We have to change micrograms to grams, then grams to kilograms. Mela micrograms, they are 10 to the minus 6 grams. So to move in that direction, we have to multiply by 10 to the minus 6. So that's 2.3 times 10 to the minus 6 grams. And then we have to change grams into kilograms. So kilogram is 10 to the 3 grams. We're moving from grams to kilograms, so in the opposite direction. So times 10 to the minus 3. Alright? Times 10 to the minus 3. Mela ħajkonna 2.3 times 10 to the minus 6 times 10 to the minus 3 kilograms. Ek tiġi. So the answer is 2.3 times 10 to the minus 6 minus 3 is minus 9. And that's my final answer. Okay? Is there anybody who managed to do these correctly? ħadd ma rnexxielu tal-mas. Alright? Għaw xaħat ieħor. Tajjeb? Okay, alright. Tajjeb. Mhumiex daqshekk sempliċi sakemm tidrom ta'. But as you get used to them, suppost mbagħad try to use this idea of using standard form, alright? Because it's a very fast method to do conversions, very fast method, and you need to do it fast. Alright, time. Now yesterday I didn't mention time, but I think that you know how to convert time. So we have to convert minutes into seconds. So how many seconds are there in 1 minute? Easy. 60 seconds. So to move from minutes to seconds, we need to multiply by 60. To move in the opposite, division by 60. Alright? So we're moving from minutes to seconds, so times 60, so 30 times 60. The answer will be 1800 seconds. J, 23. What does MS stand for? Milliseconds, tajjeb. So, milliseconds, milli means 10 to the minus 3 seconds. Milliseconds 10 to the minus 3, we're moving in that direction, so 2.3 times 10 to the minus 3 seconds, or 2.3 times 10, 23 times 10 to the minus 3, or 2.3 times 10 to the minus 2 seconds. Alright? Mela, nimxu. 2 years. We have to convert 2 years into seconds. Mela, issa attenti ftit hawnhekk. Għax di irridu nkunu ċerti fuqha. Mela. In 1 year, first we have to convert one year into days. How many days are there in 1 year? 365. Issa attenti ftit hawnhekk. Although in 1 year there are 365 days, you know that every 4 years we have a leap year, which vera, with an extra day. So, since normally we're not given the exact dates when we have to change from years to days, we don't know if there's a leap year or not. So, officially, the METSEC are giving that the amount of days in 1 year, there are exactly 365.25 days. And you will also find this in the data booklet. Alright? So actually, officially, for METSEC, you have to use 265.25 days. So actually, we're taking that extra year, extra day from the leap year, and subdividing it into 4 in the other years. Alright? Għedin niftemu. Okay? So officially 1 year is 365.25 days. Għax inti ma tkunx taf li ma snin għandek, jekk inserta hemm leap year in between. Alright? Tittati kasa dik. Fimna sawnek? Okay? Issa. So in 1 year we have 365.25 days. So first, to convert 2 years into seconds, first I'm going to convert the years into days by multiplying by 365.25 days. Mela mek nkunu ġibnihom days. Then we have to convert days into hours. In each day there are how many hours? 24 hours. Then we have to change them into minutes, sorry. In 1 hour there are 60 minutes. And then we have to change that into seconds. Alright? This is the way how to do it. Alright? Memx mod ieħor kif tagħmilha. Biex you're not to skip any step. Alright? Because there are many steps to convert years into seconds. And it is very, very, very common that you are asked to do so. If you work it out, the answer will be 6.3 times 10 to the 7 seconds. Alright? Binna? Okay. L. Għanna 45 liters. In centimeters cubed. Why did I tell you this? Again, the liters normally, they are subdivided in milliliters. In 1 liter there are 1000 milliliters. But since liters and milliliters, they are actually units of volume, alright, we have to understand that in physics we don't use liters, milliliters, etc. for volume, alright? For volume we use meters cubed, which is the SI unit, and then we can use centimeters cubed, millimeters cubed, etc. So you need to know how to convert from liters and milliliters into the units that we usually use in physics, alright? And it's actually very, very easy, because 1 milliliter happens to be exactly 1 centimeter cubed. Exactly. Alright? So if you're using liters and you have to change from liters into centimeters cubed or meters cubed, you have to remember that 1 milliliter is exactly 1 centimeter cubed. That's very easy. Alright? Therefore, in 1 liter, there are 1000 centimeters cubed. Okay? So in this case, to change to centimeters cubed, I just have to multiply by 1000. So in 45 liters, we have 45,000 centimeters cubed. jew inkella 4.5 times 10 to the 4 centimeters cubed. Alright? I didn't tell you to convert to meters cubed because we're going to do it today. Alright? Mela, M ħanaġġel ftit. 1.5 kilovolts, that's kilo, mela jiġi 1.5 times 10 to the 3 volts. N, it's 50 megawatts, which is 50 times 10 to the 6, because it's mega, or 5 times 10 to the 7, umbat tiġi, just to write it formally. And the last one, 13.8 gigayears. Alright, we have to change that into seconds. Okay, first I'm going to change the giga. So I have gigayears. Giga is 10 to the 9. So to change giga to years, we have to multiply by 10 to the 9. So that's the first thing. So 13.8 gigayears is 13.8 times 10 to the 9 years. Now, if you want to change this into seconds, because seconds is the SI unit, then we have to do exactly this same method that we did here. Alright? So times 365.25 times 25 times 60 times 60. If you work it out, let me work it out. 13.8 to the 9 times 365.25 times 24 times 60 times 60. And the answer should be 4.4 times 10 to the 17 seconds. That's the age of the universe, alright? Għalek tajtilkom ta' 13.8 għalmenu sa' kem nafu sissa is the age of our universe, 13.8 gigayears, alright? Okay, Samnek, any problems? Kulħat alright? Okay, so let's continue. So today we're going to continue on conversions, alright? But we're going to convert something a little bit different. But the basic idea will remain obviously exactly the same. So first of all, I'm going to convert areas and volumes, because till now we didn't convert areas and volumes. So if we have, for example, let's use the notes. So let's say, let's work out the first one, A. So I have 1.6 centimeters squared, and I need to change that into the SI unit. Now, the SI unit of area would be what? Meter squared. So I have to change centimeter squared into meter squared. Now, the problem when you're converting something like this is this power. Here, we're not converting centimeters to meters, we're converting centimeters squared to meters squared. And by the way, you can never convert centimeters squared to meters, alright? Ma tistax, jekk hija squared, meta ħadd ikkonverti tibqa' squared. Sound alright? So, how are we going to do this? It's very easy. If the centimeters is squared, so it's multiplied by itself, we have to convert between centimeters to meters, but for 2 times. We have to double the conversion. Why are we doubling the conversion? The idea is very simple. Because the basic formula for area is length times breadth, tux vera. And the length and breadth, both of them are types of lengths, both of them are measured in meters. That's why the area is meters squared, because actually you have meters times meters. So, to convert the area, first you have to convert length into meters. Then you have to convert the breadth into meters. That's why we have to do the conversion twice, because you're converting each side. If we have volume, which is meters cubed, we have to convert the 3 sides, so the length, the breadth, and the width, and the height. Alright? Therefore, we have to repeat the conversion for 3 times. So it's very simple. If it is squared, you have to repeat the conversion twice. If it is cubed, you have to repeat the conversion for 3 times. Let's do it. So, centimeter to meter, centi means 10 to the minus Isa. 2, tajjeb. Alright, so from centimeters to meters, we have to multiply by 10 to the minus 2. So 1.6 centimeters squared will be 1.6 times 10 to the minus 2. In this way, we have converted the length. And then we have to repeat it, times 10 to the minus 2 again, to be able to convert the breadth as well. So the answer would be 1.6 times 10 to the minus 4 meters squared. That is how to convert area. Alright? So when you have squared, okay, you have to repeat the conversion twice. Let's convert volume issa. Ħanoħdem id-D. Għandna 7.8 centimeters cubed. Alright? Jew ħanamlu l-oħra s-sanna. Ħalli nuża xi ħaġa oħra flok centimeters. Ħanagħmel E. So I have 34 millimeters cubed, and we have to change them to meters cubed, obviously. So millimeter is 10 to the minus 3 meters. So to convert from millimeters to meters, we need to multiply by 10 to the minus 3. But now, since it's cubed, we have to repeat the conversion for 3 times. Not 2 times, for 3 times. Therefore, I will have 34 times 10 to the minus 3 for the length, times 10 to the minus 3 for the breadth, times 10 to the minus 3 for the height. Okay? Meters cubed. So the answer will be 34 times 10 to the minus 9 meters cubed, or 3.4 times 10 to the minus 8 meters cubed. Alright? Tayyab? Any questions? Okay, so the rest are for homework, alright? For tomorrow. Okay? Mela, let's continue. I will send you a screenshot, as usual. Alright, let's continue the next one. Now, this is I think the most important part of this very, very, very short introduction topic. The conversion of units when they are made up of different units. For example, if we take density, alright, let me show you here because I have the send payment. Okay, let's take the first one, for example. So we have 1.2 grams per centimeter cubed. Alright, centimeter to the minus 3 per centimeter cubed. Now, if we want to change this into the SI unit of density, do you know what is the SI unit of density? Isa. Instead of grams, we have to use what? Kilograms. And instead of centimeter to the minus 3, we have to use meters to the minus 3. Okay, meters to the minus 3. So practically, when we have to convert these types of units, the most important thing to keep in mind is that you're not converting just one unit, but you have to convert both units at the same time. So we have to change grams into kilograms, but not only. We have to change also centimeters to the minus 3 to meters to the minus 3. So we have to do two conversions. Now, one of the common mistakes students make in these types of conversions is that they convert the grams to kilograms and they forget to convert the centimeters cubed into meters cubed. It's a very, very common mistake. And you have to master this type of conversion because it's very common in physics, especially when we're going to do linear motion in the next few weeks. All right, we're going to have a lot of velocities in kilometers per hour, which we have to change to meters per second. All right, to be able to use them in formulas. So you need to know how to do it. So I'm going to give you a method how to do this. And you can apply this method whenever you have these types of units which are made up of two different units. All right, so we have to convert both of them. So the first thing to do is to write this the units not near each other but over each other. That's the first thing. So 1.2 grams per centimeter cubed means 1.2 grams all over 1 centimeter cubed. Sawnek naqblu? Min ma fehmiex di. So when you have 1.2 grams per centimeter cubed, it means that it is 1.2 grams all over 1 centimeter cubed, because what we're saying here is that a volume of 1 centimeter cubed, so a box of 1 centimeter by 1 centimeter by 1 centimeter of this material, has a mass of 1.2 grams, ekettate. Alright, 1.2 grams per centimeter cubed. So that's the first thing. Then what we're going to do, we're going to apply the same method that we've done till now, that we've used till now, and we're going to change the numerator first, convert the numerator, and then convert the denominator. So I'm going to convert the numerator from grams to kilograms, and the denominator from centimeters cubed to meters cubed. Okay? So this part is exactly as we did last time. So if we have kilogram, kilo means 10 to the 3. From kilograms to grams times 10 to the 3. From grams to kilograms times 10 to the minus 3, because it's in the opposite. We're moving from grams to kilograms, so we have to use 10 to the minus 3. Mela 1.2 times 10 to the minus 3 kilograms. Alright? Till now we just converted the grams to kilograms, alright? Now we have to convert the denominator. So from centimeters cubed to meters cubed. Mela, kif ħanamlu? Centimeter is 10 to the minus 2 meters. So to move from centimeters to meters, we have to multiply by 10 to the minus 2. But since it's cubed, we have to repeat the conversion for 3 times, alright? Therefore, I have 1 times 10 to the minus 2 times 10 to the minus 2 times 10 to the minus 2 for 3 times. Alright? So, I have 1.2 times 10 to the minus 3 all over 1 times 10 to the minus 6, għax minus 2 minus 2 minus 2 meters cubed, u għaw fuq għandi kilograms. Semmek alright? Now, the final step, so first we wrote it as a fraction. We converted the numerator, we converted the denominator. Now we have to work it out to have the final answer. Alright? In this case, you have to use the calculator. Now, when using the calculator, because using the calculator, you need to know how to use the calculator correctly. When we have standard forms, as in this case, don't input in the calculator times 10 to the power of. You don't need to, alright? There's a button I think that most of you know about it, but it's important to stress it out. There's a button which is this one. This one, tarawa in the middle, times 10 to the x, alright? Which you can use to actually input the standard form directly. If you don't have that button, in the same position, you will have a button exp, which does exactly the same thing. Alright? So let's try to work it out. So first I'm going to use diffraction. Use this diffraction. I think you know how to use it. Alright? Because it's very, very, very useful. If you don't have a good calculator, be sure to buy one. Alright? Because the calculator, you're going to use the calculator all the time. So I'm going to input the first one. So 1.2. Then I just press this button and look. You have the standard form immediately, times 10 to the power, and just enter the power. So in my case, it's minus 3 all over 1 to the minus 6. Okay? It's very simple. And then just press equal. So the answer is 1200. So this is kilogram per meter cubed. Kilogram per meter cubed. If you want to write it in standard form, it would be 1.2 times 10 to the 3 kilogram per meter cubed. So we have changed 1.2 grams per centimeter cubed into kilogram per meter cubed, which is 1.2 times 10 to the 3 kilogram per meter cubed. All right? Any questions? Okay. Let's try another one. This one. هنعمل الB because we're going to use it a lot in the next topics. So 45 kilometers per hour. 45 kilometers per hour. And we have to change that. What's the SI unit for speed, Isa? Meters per second. So meters second to the minus 1. So we have to change 45 kilometers per hour to meters per second. So first, what's the first step? What's the first step, Isa? طيب, proset. So we have to write it in fraction form. Very good. So it's 45 kilometers over 1 hour. Then we have to change the numerator to meters and the denominator to seconds. Alright? Separately. So I have kilometer means 10 to the 3 meters. So times 10 to the 3. But 45 times 10 to the 3 meters. Okay? In 1 hour, how many seconds are there? So in 1 hour we have 60 minutes times 60 so that we obtain seconds. Which vera? 60 minutes and in each minute there are 60 seconds. So we have 3600 seconds. So here I can write 3600 seconds. Therefore, if we work it out, we have 45 to the 3 to the power of 3 times 3600, and the answer is 12.5 meters per second. 12.5 meters per second. So we have changed kilometers to meters, hours to seconds. Therefore, the answer is 12.5 meters per second. Now, using this method, if you're given, because you can be presented with a speed having any type of unit. For example, you can have millimeters per second, or you can have kilometers per second. Nużawhom fis-satelliti, per eżempju. There are many different types of units that we can use for speed. Using this method, you can always convert back to meters per second. All right? Any questions? Kulħadd all right? Okay. Let's move to the final part of this very, very small topic. The final exercise. I'm telling you to convert from one type of unit to another type of unit, but it's not strictly the SI unit. Sometimes you are asked, all right? to convert to a certain type of unit, but which is not the SI unit. So normally we have to convert to SI units because to use formulas, certain formulas, it is very important to use the SI units. Alright? But in certain cases, we're asked to give the answer in a certain particular unit. Why? Because, for example, let's take density. Many data tables of density of different materials, they are not in kilogram per meter cubed, but they are given in grams per centimeter cubed. All right, so you can have a problem, and then in the final part he's telling you, look, give the density in grams per centimeter cubed. So you can be forced to give the answer in a certain unit, which is not the SI unit. And in this last exercise we're going to try this. All right, let's do let's work out B. All right, for this last one. So what we're given is, we're given this density 1.36 times 10 to the 4 kilogram per meter cubed, all right, which is in the SI unit. But he's telling us to change it into grams per centimeter cubed. So we have to change it to grams per centimeter cubed. The method is exactly the same as we did before. Alright, is exactly the same as we did before, but instead of moving to the SI unit, we're moving from the SI unit to other units. Alright, so the method is exactly the same. 1.36 times 10 to the 4 kilograms all over 1 meter cubed. That's the first thing. Alright, write it in fraction form. Remember that when you're writing in fraction, if the meter to the minus 3 is placed down, therefore in the denominator, then you have to write it meter to the power of 3 then, alright? Change the sign if you place it downwards. So I have to change the numerator into grams and the denominator into centimeters cubed, ġvera. Okay? So let's start the conversion now. So kilogram is 10 to the 3 grams. That's what we've studied. So to move from kilograms to grams, we have to multiply by 10 to the 3. And actually, it's what we have to do. So 1.36 times 10 to the 4 times 10 to the 3. And in this manner, we have changed kilograms into grams. Okay? Now I have to change meter cubed into centimeter cubed. Okay? So, centimeter means 10 to the minus 2 meters. Centimeter means 10 to the minus 2. So to move from centimeters to meters, we have to multiply by 10 to the minus 2. To move from meters to centimeters, we have to multiply by 10 to the 2. Alright? In this case, we're moving from meters to centimeters. So we have to multiply by 10 to the 2. But since it's cubed, we have to repeat this for how many times? 3 times. طيب. ملا عندنا 1. طيب. ملا 1.36 times 10 to the 4. Sorry. dik فوق هنا. So we have 1 times 10 to the 2 times 10 to the 2 times 10 to the 2. ملا عندنا 1.36 times 10 to the 7 in the numerator. And in the denominator we have 1 times 10 to the minus 6 centimeters cubed. So the answer will be 1.36 to the 7 divided by 1 to the minus 6. Mela għandna 1.36 times 10 to the 13 grams centimeter to the minus 3. Għax ħadd żball. Stenna ftit. Ħadd żball jien. To the 6. Mela jiġi 1.36 l-answer. Ngħid sew? Eżatt. All right? Tajjeb? Skużawni. All right? So, I'm going to send you these 3 very small exercises, all right? To continue on working using these conversions, alright? Bħalma minna llum. And then I will correct them tomorrow, alright, during our last lecture for this week. Now, alright, so the first very small topic, it's practically finished, alright? We finished the first topic. It's not exactly a topic, it was just an introduction to be able to convert units from one type of a unit to another type of a unit. Alright, that was the reason. Now, I'm going just to introduce Eileen. Għaliex, ġara. 3.6 13 4 5 6 7 Iwa, għandek raġun, żgur. Għax għandek 7, għandek 6 times 10 tiġi 13.6. Iva, thank you. Thank you. Mela ħadżba l-ewwel, mbagħad ħadżba l-wara. 13.6 għandek raġun, sorry. Alright, kulħadd irranġa? Thank you, Ġael. Tajjeb għattu ismek? Alright. Okay, mela. Tajjeb. Okay, let's start the next topic. Issa ħanibdew the proper topics, alright? The proper topics. Mela. At the beginning of this introduction about conversions, alright? I've talked about physical quantities, and in fact you listed some physical quantities, alright? You listed some physical quantities, and then we saw that the physical quantities are quantified by their units, so vera. But when talking about physical quantities, not physical quantities are exactly the same type of quantity. What does this mean? There are physical quantities, for example, mass. Which actually they are defined, they can be described by their size only. For example, if I say, look, I have a box and this box is has a mass of 5 kilograms, alright? I have actually described everything about the mass, ux vera. It's 5 kilograms, it has a mass of 5 kilograms, full stop. The 5 kilograms is the size of the mass, vera, is the size of the mass. Now in physics, size, normally we use another word for size, which is magnitude. So these types of physical quantities alright, they are fully described by their magnitude only. Magnitude means size, alright? For example, another physical quantity which is described by its magnitude only is temperature, for example. So if I say that the temperature is 300 Kelvin, full stop, 300 Kelvin, I'm describing everything. I'm describing the temperature of the air in the room, for example. Okay? So I'm describing it, and it's enough. Memx bżon nagħti iktar informazzjoni, vera? 5 kilograms, 300 kilograms, that's it. But then there are other physical quantities. Which cannot be described by their magnitude only. Ħantikom eżempju, for example, wind speed. Jekk jiena ngħidilkom isma' the wind speed is 20 kilometers per second, per eżempju. Alright? 20 kilometers per second. Duni għaf sem. If I give that information to a sailor, is it enough? I tell him, look, the velocity, the wind speed, the wind velocity is 20 kilometers per second, full stop. Is it enough? No. I have to give? Sorry? What do I have to give? I have to give direction as well. Alright? It is of no use of giving the magnitude of the wind speed without giving the direction. A sailor can do nothing without the direction. Edin niftehmu. So there are certain types of physical quantities which have to be described by their magnitude, okay. but also by their direction. By the direction. For example, wind velocity is one of those types of physical quantities. Another important physical quantity which has to be described by the magnitude and direction is force, for example. It is of no use to tell you, look, apply a 5 Newton force, on that box, okay, but in which direction? If I apply it in a direction parallel to the floor, for example, it will move along the floor. If I apply it vertically upwards, it will move upwards. It's completely different. These types of physical quantities, which need to be described by their magnitude and direction, they are called vector quantities. The quantities which are described by their magnitude only, which do not need any direction, those are called scalar quantities. Alright? Scalar quantities. I'm going to stop here. Tomorrow, we're going to continue on this topic, alright? Scalar and vector quantities. Okay? Kulħadd alright? Tajjeb? Mela narakom għada jiena. Okay? Ciao ciao. Bye bye.